Let's start our discussion of functions by looking at function notation. So here's what function notation is. It's a special type of notation where instead of just assigning the output value of a function to some variable, to some letter, we're going to use this notation so that we can name the function, so we can know what function this output value came from, and we can also know what was the input value that gave us that particular output. And so, seeing this will make a lot more sense. So let's take a look at this very straightforward example here. In this example, what we usually did in the past was we just called it y and x, and that's how we paired up inputs and outputs. So in an example like this, I would plug in, like for example, if I plugged in 1 here, right, and this would become -3 times 1, right, which is -3, plus 1, which is -2. Right? So I would turn this into a -2. And so what this means is when I input a 1 for x, I got back a -2 for y. And so that's what we mean by inputs and outputs. I input something for x, and I get something back, and then assign that output to y. So what we're going to do that's different is we're going to change it and say, you know what, let's not use y, because if I just, on some blank page said, oh, what happened? Y equals 2. Okay, I would look at this and say, okay, well, I don't know what function you input to get this to, and I don't know what value you input to get this to. So when the notation looks like this, I don't get any information about where it came from or what I used to get it. So we have this other notation. So if we go back, instead we're going to write this little notation here, which is called, when we read this, we read it as f of x. Okay, so when we're talking about this, the f of x, first of all, replaces y. Instead of using that letter, we're going to use this notation f of x. Okay, here's what this means. The first part of this, okay, the f, is not a variable. We're not going to replace anything there. This is the name. Right? So I'm going to name the function f. So you can use any letter that you want or any symbol that you want to name the function. It could be, a lot of the other common ones are G and H and J, kind of in that same space, but you could use R or S, anything that you want for the name of the function. Okay? This value here represents what we are going to input for on the other side. So this is actually is a variable. This is the input variable. Okay? And so what we're going to do when we input into a function is we're going to replace this x with whatever we want, and then see what comes out. And so I'm going to just show you on the next function. So again, let me just emphasize, f is not a variable. You will not replace it. It's just what we're naming the function. So whenever we say f of a number, we can know that it came from this particular function. Okay, so let's take a look at some examples. Okay, so if you take a look at this, I'm giving you this function g of x. Okay, so I'm just going to highlight our function because we're going to refer to it a few times. So this function right here, g of x. Okay, so we know that any time somebody makes notation that looks like this, they're actually telling us go to the g function. Right? Wherever there used to be an x, I've replaced that with a 1. So I actually want you on the other side. Wherever there used to be an x, I'm telling you to input 1. So this is really what your function notation looks like. Go to the g function, plug in a 1, tell me what comes out. So I would go to this and I would say g of 1 is equal to 4. They asked me to replace every x with a 1, so I'm going to do that, minus 12. Okay? So this looks like 4 times 1 is 4. 4 minus 12 is -8. So this is what I'm going to write. G of 1 is -8. Okay? And so this is why we like this. If you take a look at this piece right here, I know everything I need to know about this function. I know that it came from the g function. I know I plugged in a 1, and I got back a -8. Compare that to this. When I'm looking at this, I don't know where it came from. I don't know what I plugged in. So this notation is what we're going to use so that we know where it came from and we know we plugged in. So I'm not going to go through all of these examples. Just to do one more really quick, let's do, for example, g of 7. I'm going to say g of 7, which means go to the g function, plug in a 7. So that means it's going to look like 4 times 7 minus 12. Well, 4 times 7 is 28. 28 minus 12 is 16. So I'm going to say the g function, when I plugged in a 7, is going to be 24 minus 12, which is 16. Okay? So this is, again, same idea. I just replaced the input value with a 7. Right? So the other possibility is, over here, I might say, you know what, g of something, the output should be 4. So in this case, I'm actually using right here saying this is the input, this is x, okay? Here I'm saying I don't know what x is, but I know I'd like a 4 to come out of the equation. So what we're going to do is we're going to go right here, and we're going to replace the whole g of x. They're saying, here's what g of x is. That output I want to be 4. So I'm going to do that. I'm going to say this as, instead of writing g of x, I'm going to put 4 is equal to 4x minus 12. They're asking me to find out what is the x value so that I output a 4. Okay, so I'm going to now solve this. This is just regular Algebra 1 solving. Add over the 4, and I get 16 is equal to 4x, which means that the x value, the input value, has to be, when I divide both sides, has to be 4. And I can do the same thing with the next one. Right, they're saying, go to the function, everywhere where there used to be a g of x, I would like the output to actually be 20. Right, so they say, go to the g function, I want the output to be 20. And so that's what I'm setting this up to be. Okay, ooh, that's a 12. Okay. And so again, just solve this. If I add the 12 over, I get a 32. Okay, and then if I divide both sides by 4, it looks like I get an 8. So they're saying, if you'd like a 20 to come out of the g function, you need to input a value of 8. Okay, so on my screen, don't worry about the stuff about domain and range. We're going to talk about that in a little bit, but we're just kind of getting into the very basics of it. So this is, again, still this idea of inputs and outputs, but we're just using a different notation to get into it. Okay, so we're going to skip the try, and we're going to write on to graphs. Okay, so when we talk about graphs, if I, again, think about that equation that we just had that said y equals negative 3x plus 2, if I asked you to graph something like this, what we would traditionally do is something like this. I would make an XY table, and I would pick some values like negative 2, negative 1, 0, 1, and 2, and I would input. Right? I would look at this and I would say, when I input a negative 2, what comes out for y? Well, it looks like when I put in a negative 2 here, this becomes 6. 6 plus 2 is 8. Right? And so I could go through and kind of generate a list of x's with their y's, and this is a point. Right? Negative 2 is my x. We usually will say this as like as x comma y, right? And this is a point that I could then go over and put on the graph. So when we're talking about function notation, the only difference is that we're saying it's x comma f of x, and the f of x represents what comes out for each x that we plug in. So let me get rid of this specific example and take a look at what they're asking about. Okay, so if I'm looking at this, it says find f of 6. So what they did was remember, if we're talking about f of 6, we replaced x with a 6. So this is like 6 comma something. And this one's doing the same thing. It's saying there's some point on this function that they're calling f that is negative 4 comma something. And they want to know, what is the something? What is the output when the input was 6? And so we're going to go over to our graph over here, and we're going to look. Okay, so on my graph, if I go to the x value of 6, I'm going to count over, and it's 1, 2, 3, 4, 5, 6, and then go find my graph. It looks like I have to go up to 2. Right? My y-axis is 2. So I'm going to say on this particular graph, which they called f, and sometimes you'll see an f at the end of the function to note that this is the f function. When we go over to 6, we have to go up to positive 2 as the output value for that function. If I go to negative 4, that's right here, it looks like I have to go down to negative 4. So my output value on the output axis, which we used to call y, right, we're going to say is negative 4. Okay? And so this last one is, again, that opposite. It's saying, I know the output is 4. If the output is 4, what is x? Like, what's the input so that my output can be 4? So I'm going to go to my output axis, my y-axis, and say 1, 2, 3, 4. Where's the graph? It looks like it's all the way over here at 9. So my x is 9 to get an output of 4. So I'd say x has to be equal to 9 so that when I plug that in, I will get a 4. So this idea of function notation still applies to graphs. Before, when we were looking at regular old inputs and outputs here, we said every time that we used to have a y, let's call it f of x. So when we're talking about graphing, it used to be x comma y, now it's just going to be x comma f of x, and we can do the same thing. Okay, so let's do a couple more examples using graphs. Okay, so I have an example here. The first picture is a graph, and it says the graph represents f. So I'm just going to kind of come over here and again just mark this with an f. Okay, the table of values represents g, which is a different function. And so this is the idea of naming the functions. I need to specify that the one on the left and the one on the right, the table versus the graph, are different functions right? And they're asking us questions about them. So the first one says, if f of 5 is equal to r, what is g of r minus 3? And so that's kind of a pretty dense question. So let's kind of start off with the first part. It says if f of 5 is equal to r. Well, let's see if we can figure out what f of 5 is, and then that's going to be r. So I'm going to go to my f function, which they told us was the graph. So I'm going to go over here, and it says f of 5. So I'm going to say they told me the input was 5. Okay, and I'm going to say 1, 2, 3, 4, 5. Where's there a graph? It looks like I'm going up to 1, 2, 3, 4, 5, 6. So that means that f of 5 is equal to 6, and that means that r is equal to 6, right? So that means I can come over here and say, well, this is really saying g of 6 minus 3, which is really just g of 3. And now I can go over to the g function, which they presented to us with a table, and I can do the same thing and say, okay, what is g of 3? Well, what is the output value when I plug in a 3? And well, that's this line right here, right? They're actually saying when I plug in an x value of 3 into the g function, I'm getting back 4. So the overall answer to this question, what is g of r minus 3? Well, it's 4. Okay, so this is, again, kind of a dense question, but it's using that same type of information. So let's try the second one, same thing. All right, and they're saying g of x is negative 5. So I'm going to go to the g function, okay, and remember, if the value right here was filled in, if the x was filled in, that's the input. This is the opposite. This is saying, I know the output from this function is negative 5. And so I'm going to go here, and I'm going to say, okay, the output value is negative 5. That means that x has to be negative 3 in order to get a negative 5. So that means that I can come over here and say, well, this is really saying f of, I know what or x is now, so I can say this is f of negative 3. And if I go to my graph, okay, if I go to my graph and go over to negative 1, negative 2, negative 3, I can then go up and say f of negative 3, the overall answer to this question is f of x has got to be negative 4 when x is negative 3. Okay? So I'm not even going to do the last one, same basic idea. Okay? And so that's function notation. It's just a different way. Instead of talking about x's and y's, we're talking about x's and f of x's or g of x's, so that we can have a discussion about the inputs, and we can also know where the function came from.